Oh, hello, good evening, everyone.
Good evening.
Good evening. Am I audible? Hello.
Yes, sir, you are audible.
Okay.
Yes, sir.
Okay. So, how was quiz one paper? Anyone? How was quiz one? Is what difficult, easy, hard, medium?
Maths easy.
Okay.
Easy, sir, easy.
So it was manageable within the time, right?
Yes, sir, yes.
Okay. Great. So today we'll start with the week six now. So how many of you have watched the week six lectures? Please raise your hands. Okay. Great. So we are dealing with the logarithmic function in this week. So today I will quickly summarize the content and we'll take few questions from activity and practice. And later, if you have any doubt, you can ask. Okay. So is my screen visible?
No,
Hello?
so yeah.
Yes, sir. Yes, sir.
Okay. So before starting, uh, so let us discuss about the first exponential function. Say we have function f of x equals to a to the power x. Okay. And I'm putting the constraint a greater than should be 0 and it should not be equals to -1. So anyone can tell me why I have put this constraint? Yes, anyone? What is the reason for that?
1 power anything will be equal to 1.
1 power
And sir,
anything
if
will be
it
equal
will,
to.
and if it will be,
Yes.
If it will be
Yes,
less
can you
than
please
0,
repeat?
then it
if it
can
will be
become
less than
complex
0,
number.
then it will.
It can become complex number.
Okay.
Yes, sir.
Okay. So what will be the range and domain of this particular function?
Domain is all real.
Range is real.
Range is real number, all real.
Domain is
Or
real.
domain. Yeah. So domain
Domain
is
is
so
real
it will
number.
be
Range
from
is
Domain.
minus
zero.
infinity to
Range is
infinity, right?
0 to infinity. Yes.
And
Range is
range
0 to
is 0
infinity.
to infinity. Now, if we see the logarithmic function, okay, it is the inverse of this particular function, exponential function. So that is f of x equals to log to the base a x, right? Now here I
Yes,
am
sir.
saying x is should be greater than 0 and same constant that I have applied, x is greater than 0, sorry, a is greater than 0 and a is not equals to 1. So please note that the value of x, value of any function here, if it is composite function, should be greater than 0 always. So this condition is must. So based on this condition only, we can solve many questions from activity or from practice. Okay. Yeah. So since I am saying that logarithmic function log of ax is the inverse of this particular function, so what should be the range and domain of this particular function, this logarithmic function?
Domain will be 0 to infinity.
Yeah. So this range will become the domain of this particular function, right? 0 to infinity, and the range will be
All real
minus
number.
infinity, yeah, to infinity. It is range, right? So this is the basic, you can say, definition of our properties of a logarithmic function. So our x should be always be positive and base a should be greater than 0 and should not be equals to 1. Okay, so what will the graph look like when say suppose a is greater than 1? In that case, this is y, this is x. It will be increasing or decreasing from left to right?
It will be increasing.
Increasing, right? And asymptote will be this y axis,
Yes, sir.
right? Vertical asymptote. Okay, so this is when a is greater than equals to 1. And when A is from 0 to A, from 0 to 1. In that case, what will the graph?
Reflection about x-axis.
So that will be like this. Okay. So this is a graph for
Yes, sir.
from when A is between 0 to 1. Okay. And what will be the x-intercept in this case?
1, 0.
1, comma 0. Right. Yeah. So this is a basic graphical representation of a logarithmic function. Okay. Okay. So then there are two things. One is natural log, and other we generally say as say common log. So what is natural log?
E.
Yeah,
Base
log
E.
to the base
Logarithmic
E.
E.
This is a natural log, right? So in general, we
Yes.
can write it as ln only, ln of x. Common log means log to the base 10. So that is log to the base 10 is generally a common log, right? So generally, if you see, we represent by log only, that is log of x. So suppose in the question it is not mentioned which base it is, so you can simply assume it is log to the base 10. If ln is mentioned, it is natural log. Okay.
Hello.
The properties will be same as the logarithm function only. So keep
So
this in mind. Yes.
the graph that you have drawn here, which for a greater than 1, can you explain why it is like that?
Okay.
I didn't understand this particular part.
Okay. Say suppose do you know what composite function, right? Say suppose I have f of x is x and say g of x is say log of x. Log of x, okay, say g of t is t. And I want g of f of x. Okay, so that basically log of x only. So what is the graph of x?
F
What is the
of x
graph
is
of
equal to x will be like y is equal to
this
x,
only,
straight
right?
line.
Yeah, but we are constructing domain here, that is x should be greater than 0, right? So we are not dealing with when x is less than 0. Okay, so that should be this
Is
like
it
this.
is it because x cannot be less than 0 when it is
Yeah,
for a log?
for a log, yeah, it cannot go on the negative side. It
Okay,
cannot take the negative value, right?
I'm asking this question particularly because in one of the lectures, we have solved a problem which is log 4 to the power minus x. So how should that one be considered?
Minus x, this one.
Yeah. Log 4 to the power, log 4, sorry, log minus x to the base 4.
The base 4.
Log minus x to the base 1 by 4, sorry, 1 by 4, but whatever.
1 by 4. Okay.
So that is, there is a problem like that. So that is a negative number, isn't it? So, but we always say
no,
that
here
it cannot
x
be
can take negative value, then this whole term will become positive, right? So I'm talking about minus x should be greater than 0 in this case. Say log to the, say any base say minus x, right? This is your function. So what is the condition? X should be greater than 0. That is minus x should be greater than 0. Means x can take negative values, right? Then it will become positive.
Okay. So
Still the graph will be look like
output
this
should
only.
be positive. The output should be
Yeah.
positive. X can be
Positive.
negative. Okay.
Yeah.
Okay. So in this case, then x has to minus x has to be greater than 0. All right. Okay.
Yeah. All right. So in say suppose in general I'm talking about log of say any function f of x. That f of x should always be greater than 0. It can be minus x or minus e to the power x anything, but it should always be greater than 0. So I have one example like that. We'll discuss that part also. Don't worry.
Thank you.
So this is basically a simple summary of the week. Nothing in it, but the important thing is the property of this logarithmic function. Okay. So properties. Okay, but the important point from the previous slide is that log to the base x means x should always be positive. Means any function should always be positive. So based on this only we can solve many questions. Okay. Now I'm coming to the properties of the logarithmic function. So the first one is that is log of say any base a m n, it should be log of a to the m to the base a, log of n to the base a. So base should be same. It is not like that log of say 10m plus log of 2n. So you cannot write it like log of mn, right? So base should be same. Here also a, here also a, here also a. So base should be same. Now second property is log of m by n, right? So that is base a. So log of m to the base a minus log of n to the base a. Okay. Then there is a power property. Say log of a, say m to the power r. Then r will come on this side. That is r of log of a to the base m. Okay. So please remember all those properties. It is very important. Okay. Then next one is say log to the base a. Say we have 1 by m, right? So I can write it as minus log of a to the base m. This is one of the property again. And also one important thing is just log of a to the same base. Means base is also same and this a also same. So in that case it will be 1. And log of 1 for any base it will be 0. Okay. Yeah. So log of 1 is 0 for any base. And if the base and this variable is same, then it is equals to 1. Okay. So any other
Sorry,
properties remaining?
what is written there? Log m to the base 10 log n to the base 2 is equal to, sorry, is it log mn?
This one. Yeah, it is not. Yeah, this is not valid.
Above,
Say
above log a comma a, above log a to the base a, you have written something there. Sorry,
this one, na?
I am not able to see the cursor, so I don't know which one you are pointing.
This.
Yeah, above that, what you have written.
Okay, this one, right?
Yes.
It is not correct. It should be the base should be same. So log to the
Okay.
base, log of m to the base 10 and log of n to the base 2. It is not equal to log of mn. Okay, so the base should be same. Yeah, this is not correct. So please remember while applying this formula, you have to keep the log base same of the log. Okay, then only you can apply these properties. Now there is something called change of base rule, right? Change of base rule. So suppose I have log of x to the base a. So I can write it as log of x to any base, that is b, say b, and log of a to the base b. Okay. So in general, whenever you are using these properties, so always consider log of x to the base natural log of e. Okay, I will tell you why, the reason behind it, because it will simpler if you make all the expression in the same base. Okay, so generally we take natural log only. So just you can write it as log of it is also equals to ln of x upon ln of a, so to the base e. Okay, instead of b, but in general you can write any base. Okay, so that is no issue in that. So this is the 5 properties. Any other remaining? Anyone? I guess one more thing is that s log of c to the base. So here I am talking about in the base power. So a to the power b, it is in power. So it is equals to 1 by b. So whatever is there on the power, it will come in the denominator 1 by b, and then log of c to the base a. So this is also important property. Okay. But in general, please remember this one, and change of base rule. Once you apply this first change of base rule, your all the expression will have the same base. Then you can apply these 3 basic properties. Okay, so these are derived from this basic only. So you can apply that. No issue. So any issue in this properties of logarithm function? Any doubt in this part? Anyone?
Sir, can you explain the last property, so 60?
Okay. Say I have log of c. In the base, it is a to the power b. So I can write it as 1 upon b log of c to the base a. So how I can write it as? Is anyone can tell me the derivation for this?
Yes, sir.
Yes.
Sir, we will convert it into log to the power a base.
Log to the power.
We will change base by log to the power a, log base a,
So how we'll do that?
by fifth property.
by using
By
property.
using property 5. We can use property 5 to justify it.
Change of base rule.
Yes, sir.
Yes, sir.
We will change
you are-
base by a.
So log of c to upon log of a to the power b. You are like this, right?
Yes, sir. And
Say
base
it
will
is
be a.
any log e. Okay. Now
No,
this
sir,
b
a.
will come this. Okay, you can apply any base, no issue. A it is fine. So if you are saying a, so that is a. Log to the
Now
base
we will
a,
apply
right?
third property.
No,
Yes,
here
sir.
you cannot take a because it will become 1, right? So in the base also it is a. So you can take any base. It is not necessarily a only.
Yes,
So
sir.
I'm
But
taking
for
general
proof, we
log.
will need.
Yeah, I'm taking log of e, right? Now here
Yeah.
log of c to the base c will become like this. By using this property, third property, I can bring this b this side, right? B
Yes, sir.
log of b to the base e. Now 1 by b, that is ln of c upon ln of b. Sorry, ln of a, right? Now which one is applied? Now okay. So here you can see chain of base rule. You can apply in the reverse order also. That is 1 by b. It will become log of c to the base b, right? So log base a.
Yes, sir. Yes, sir.
So this is the derivation. Anyone, any doubt in this part? So that's why in the beginning I'm saying first apply the change of base rule and then just apply these basic 3 properties. You can solve any equation, okay? Any problem, and you can remember this also. This all the derived from other properties will be derived from these basic properties only, like this. But if you know this, then your calculation will become much simpler, right? So this is one of the property. Okay, anyone, any doubt in this part? I think this is the summary of week 6. Nothing in it. These are important properties and application of that properties. And please remember, in the log we can take only positive values. Okay. So let's solve any practice activity question. Do we just 1 minute? Okay. We'll start from the beginning only. Sure. Okay. This is the first question. I have taken this question from activity and practice assignment. Okay. So yeah. Just anyone tell me how to solve this question? So this is 3 to the power x plus 2. It is 243. Find the value of x.
So we can write 243 as 3
We
power
can
1. So we can write 243 as 3 power 4.
To the power 5, right?
Yes.
then
X plus
take log
2 equal
both
to
sides.
x equal to 3.
I can take log on both the side,
Both sides.
right? There also log of
And
say
then
natural log 3 to the power 5. So it will be x plus
and
2
x
ln of 3, and here it will be 5 ln of 3. So this will get cancelled. Now I can say x plus 2 equals to 5. So x equals to 3, right? So this is the answer. Anyone, any doubt in this part? Simply applying one property of log here. That's it. This activity question, you can do that. Now one more question. We have to solve for x only. Here e to the power 4x minus 2 to the power x minus 12 equals to 1. Tell me how to solve this question now.
but we can take 1 to log e to the base e.
So 4 power x minus 2 power x minus 12 equal to 0. So
So minus y 0 because log to the
if
base
our-
log of 1 is to the base c, right? Because this will go on this side, right?
yes,
So it will become the log of this particular thing. So log of 1. So that is equals to 0. Now I have
2 power
2
x
to the
as
power
base.
x.
Write 2 power x
Yeah,
as
yeah. So I can write it as 2 to the power 2x minus 2 to the power x minus 12 equals to 0. Then
Take 2 power x as
T or something.
2 to
yeah,
the power
it's-
x is equal to
it's
t.
t. So t square minus t minus 12 equals to 0. What are the root?
3, 4. 3, 4.
Min
3, 4.
minus 4 plus 3. So it will be 4 minus 3, right? Equals to 4 and
Yes.
minus 3.
Yes.
Yes, sir.
So t equals to 4 and minus 3. Now I have to equate this, right? 2 to the power x equals to 4 or 2 to the power x equals to minus 3. So is it possible for any power for x, do we get a minus 3 value?
No.
No, sir.
So this is invalid. And for what value of x we will get 4?
2.
2.
Right? When x equals to 2, I will get 4. So only the answer 2 is correct, right? So you understand why I'm taking I'm not considering this value, because 2 to the power x is equals to minus 3. It is not valid. Okay, so we can consider this thing only. Okay, 2 to the power x equals to 4. So answer will be 2 only. Anyone any doubt? Simpler calculation, simple one. Okay, now tell me this question. Hello, yes, anyone?
Using
We can apply
Yes, sir.
multiple
Base
Sir,
is
we
same.
can apply
We can
property.
the rule of
apply.
Use property first. Property number 1.
Okay, so log of mn equals to log of m plus
Base
n.
same, so we can say multiply.
The
Okay,
answer
so
will
here
be
I
minus
can
4 and
use
4.
log of n, log of
four.
n, right? So I can equal to log of mn, right? So this property I can
Yes.
apply.
Yes.
So log to the base 12, because base is same, I can apply this property. X minus 2, x plus 2 equals to 1.
मार क्यों रहा है इसमें? ये स्टिल लग रही है ये. उसको तो लग रहा है.
Hello? Okay. Okay, then I can apply the formula, that is x square minus 4, right, equals to 1.
So 12
Now,
equal to x square minus 4.
okay, so now this 12 will go on this side, right?
Yes, sir.
So it will be x square minus 4, 12 to the power 1, right? So whatever the number we have, it will go in the power of this particular base, right?
4.
So now I will get
Yes, sir.
x square equals to 12 plus 4, that is 16, and x equals to plus minus 4.
Minus 4.
But we have to only take plus 4, right? Minus 4 won't be considered.
Why? Why we are
But
not
like
considering this value?
Sir, for example, log to the base 12 x minus 2. There, if we put x
Yes.
equal to minus 4, then
It will become minus 6, right? So it is not in domain, right?
Not possible. Yes.
Yes.
Yeah. So we cannot consider x equals to minus 4. So x equals to 4 is the answer. So that is the way. So you have to check whether the answer we are getting, if we put in the function, so that should be greater than equals to greater than 0. Okay. Then only that value for x will be valid for this particular function. Okay. So this is the one more question. Now tell me how to approach this. Anyone? Here we have to find out the number of solutions. Yes, anyone? Same
Can
thing.
use
Think
property
about
too.
the
Yes, sir.
properties.
Same thing.
Yeah.
Yes, sir.
reason.
So we can
We
apply
can use
log a
second
minus
property.
log b.
So log of equals to log of m by n, right?
It can be changed.
So log of
X square by 4
upon x minus 1, right?
equal to
Equals to
1.
what is this value? 1,
1, sir.
right?
1.
Yeah.
It can be written
Now this is log of e, right?
E. Yes,
Yeah.
sir.
Yeah. So I can take e on this side.
Yeah.
Yes.
X to the power 4, x minus 1 equals to e to the power 1, right? That is e. Okay. Now I can simplify that. X square equals to 4x minus 4 into e. That is 4xe minus 4 into e. Okay, now tell me how should I approach? Yes, anyone?
By comparing the coefficient of x and x square.
So I have this expression now, x square minus 4xe plus 4e equals to 0. Now I have to find out the number of solutions for this particular expression. So what should be the value? Yes, anyone?
We
We
will
can use Dharacharya formula.
We can check. We can check discriminant.
discriminant.
yes, sir.
Sir, how are you taking the e to the right hand side there directly? Is 1 not equal to e to the power of 0 already?
So here, how 1 came, right? Are you asking?
Yeah. Now, how are
So
you
here you
taking the
can
e to the right side directly? Because the
Okay.
log has now disappeared from there.
Yeah. So in general, say log of x to the base a equals to say any number, say m. So what we can do, we can simply take this base on the
A to
right
the
hand side.
of m is
and-
equal to x. Yeah.
Yeah. So that will be a to
Apply
the
rule
power
of
m
7.
x.
Yes.
Yeah. So same thing I'm doing here, e to the power 1, and this is the function, right?
Yes. Okay.
Yeah.
Sir, I have a doubt, like how we got ones on the right
Sorry.
hand side. How we
How e
got
to the
one
power
on
1?
the
5 to the base 5.
Here you can see log of 5 to the base 5. That is equals to 1. So we have one property, log of a, set the same base, if we are having the same base as number, so it will be equals to 1.
okay. Sir.
Log of a to the same base a, it is equals to 1. So same thing is here also, right?
Okay.
Now tell me what should be how should I calculate this here? So you have someone is saying about determinant, right? B square minus 4ac.
Yes, sir.
Okay, tell me.
So b square is
It is
16.
equal to 0.
So b, what is b here?
Is 0.
Minus
Uh,
4e.
Minus
4
4e.
4e.
Right. So it will be 16e square minus 4 into 4e into 1. So 16e square minus 16e, right? I'm not getting anything. So what should we do? E is basically 2.17, right? When it's in number is there, right? So we'll get one positive number. So it is always equals to greater than 0, right? Sorry.
Yes.
Yeah.
Yes.
Then what should we do?
Solution.
It has real solution, but how should I approach this? I want number of solution, right?
It is a quadratic
चिकन नाम पानी वानी
base
मिल पड़े डाला एकदम सर्च एकदम बढ़िया डाला कुछ भी करो सिंक लग गई
Yeah, please.
सिंक लग जाएगी यदि टाइल लगवाओगे वरना सिंक ऊंची रहेगी उससे
Please
स्लिप
be mute.
टाइल कितनी आएंगी टाइल तो ज्यादा ना बताइए उसने 2 बार
Hello, please be mute.
Hello. Yes, yes. I have noted. Okay. Tell me.
D is greater than 0, so we can say that there are two roots.
So there are two roots, right?
Yes, and
So
coefficients
number
are
of
real.
should be 2. Yeah. So one thing. Okay. So hello.
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
So this is the so is greater than 0 means it has the two real root, right? But here you have to check for this particular domain. It cannot take x equals to less than minus 1. Sorry, less than minus 1, right? So less than 1. So do we have that number? So yeah, it is not possible. So x should not be equals to 1. So let's put here 1 minus 4e plus 4e. So 1 is there. It is not satisfying. So 1 is not in the domain. Yeah. So we can say we have a two distinct real root here. So that will be 2, right? So answer number of solutions will be 2. That's it. Yeah. Okay. So
Sir,
yes, anyone?
sir, how you get to know that it is less than or more than 1? Like x is equal
sir.
to
No,
more
no.
than 1.
If x equals to 1, then its term will become 0, right?
Yes.
So I'm just putting whether it's x equals to 1 is satisfying this particular equation or not. I'm just checking it. That is 4e plus 4e. So it is 1. It is not satisfying our condition. So 1 is not there in the two real root, right? So
Okay.
yeah. So the number of distinct real roots are 2 here. So you can say number of solutions are 2.
Sir, if we'll put x in negative form, then it is valid. Like
No,
if
this
x
function is not valid. No, then so x if you
Okay.
put minus 2 minus 1, then ln of minus c will be there, right?
Okay.
So this is not valid. I have one more question like this, in that we have to check this in this question. Okay.
Okay.
I'll come to that. Now this is the unique question. How many digits are there in this particular term? Now tell me how to approach this question using the log. Anyone?
No idea, sir.
Number of digits we have to find out, right? Anyone, any idea?
Give some time.
Okay.
So do we need binomial? Because
Binomial.
Sir,
Means,
sir, can we do the log 15 then in the power log 7?
if you take the log of this particular function,
Yeah.
so it will be 7 square log of 15, right? So any base say e. It will be 49 ln of 15. We want now how many digits are there in this particular term? Digits, not the value of this. Digits.
We can write ln of 15 as log 5 plus log 2.
Yeah, but do we know from that, do we get the digits, number of digits in a particular term?
No, sir. No approach.
Can you give time for 2-3 minutes?
Okay, yes. Think. So it is something related to the base 10, log to the base 10, common base. Now just think about that.
So can we take log base 10 of 15 raised to power 7 square? Then if suppose we get value is equal to 1, then we have 2 digits, 2, then we have 3 digits. And similarly, if we have m value, let's suppose then we have m plus 1 digits.
Okay, how do you know that? How do you come to know that?
So I did
Reason for that?
some experimenting, like I put log 10 1 and I got 0, and 1 is clearly a single digit number. So I recognized a pattern that log 10 part and 10 is equal to 1 and log 10 100 is equal to 2. So
Right.
that's
Yeah, that is correct. So I'm drawing this line. Let us say number n. I have 1 to 10. Then this is 100. This is 1000. And this is 10,000. Okay. And I have this log to the base 10. Okay. And n of this n means log of n to the base 10. So log of 1 to the base 10, that is 0. Log of 10 to the base 10, that is 1. Log of 100 to the base 10, it is basically log of 10 to the power 2 to the base 10, that is 2, right? So it will be 2. Here 10 to the power 3. Here 10 to the power 4. So it will be 3 and 4. So this is n, 1, 10, 100, 10 to the power 3, 10 to the power 4. And this is the value of log of n to the base 10. 0, 1, 2, 3, 4. Okay. So till now, any doubt like whatever I have written here? Any doubt in this part? Anyone?
No, sir.
No, sir.
Okay. So in 1 to 10, there will be one single digit number, right? Say 5, 6, 7, 8, right? In this particular range. And the value of this log function will be 0 point something, right? It is 1 here, but between when the value of n is 1 to 10, so the value of this particular log function is 0 point something. It is getting 1 when when n equals to 10, right? Now same here, the value of log this particular function when the value of n is between 10 to 100, that is 1 point something, right? Here I have one digit. Here I have two digits like 11, then 29, 59, 99. Similarly, here I have three digits number from 100 to 1000. And here I have four digits number from 1000 to 10,000, right? And here the value of log function will be 2 point something. Let me use the different pin. That is 0 point something, right? And here 1 point something. Here 2 point something. Here 3 point something. So if you observe this, the value of this log of 10, the left hand side of the decimal digit 0 plus 1. So here it is 0 plus 1. It will be a number of digit of this particular function, value. Okay. So in this case, I am talking about, say, suppose I am getting 2 point something for any particular value. So in that it will be 2 plus 1 digits. Okay. It will be 3 digits. And here you can see for 3 point something, if you are getting answer 3 point something, the number of digits will be 4. Similarly, if we apply the log of 10 to the base particular this number, whatever the value we are getting, add 1 to that, and that will be the your answer. That is the number of digits. So this is the concept behind that. Anyone, any doubt in this conceptual part? Anyone? Hello? Anyone, any doubt? So whenever you are seeing this type of question, how many digits are there in particular number? You just take the log of 10, that particular number, and find out the value of that. Okay. So this 7 square will come on this side by power rule. Then 49 log of 15 to the base 10. So value will be like, it will be something, total value will be 57 point something. Okay. So but we want number of digits. So the number of digits will be 57 plus 1, that will be 58. Okay, just calculate the value. I think it's 57 point something, and plus 1, that will be 58. Anyone, any doubt in this part?
Yes,
Should
sir.
we add
Then,
ones?
sir,
Not
sir, I
much,
have a
like
doubt. Like,
confused little bit.
oh, then 7 square, then it has no meaning. Yeah.
7 square, it is 49, right? I'm bringing this down. So that is 7 square log of 15 to the base 10. So that is 49. So if you multiply 49 with the value of this particular expression, you will get something 57 point something value.
So why should
And
we add
add,
one?
sorry?
Why should we add one to the answer?
Yeah. So here you can see this is a number. So 1 to 10, 10 to 100, right? So when my number is between 10 to 100, that is 2-digit number, I am getting the value 1 point something for this particular log of n to the base 10. If my n is between, say, 1000 to 10,000, that is 4-digit number, my value will be 3 point something. So I know if I add 1 here, I will get that number of digit in that particular term. So here 2 point something means I will get 3 digits number. You are getting a value. Yes.
Are we then expected to know this value of log 15 to the base 10, or will that be given in the question?
No, you can use the calculator. No? The portal calculator is there, right?
Okay.
Yeah, you can
Sir,
simply use this calculator for this finding out the value.
sir, how it got 57? 49 into that log is equal to 57.
Yeah,
That's
yeah.
it.
49 particular
Okay.
value is log of 10 to the base
Oh,
15.
okay.
If you see the portal, let me share my screen. So that is 15, right? So log 10 means here you can say simply log only, log to the base 10. So log to the base 10, 15 is 1.17 into 49. That is 49. This equals to 57.62. But if I know by this property, if I add 1 to that, I will get the number of digits in that particular term. Right? Hello?
Yes, sir. Yes.
Yeah. You can use the calculator available on portal. In TCS exam also you will get the same calculator, right? You can do the calculation. Okay. So I hope you understand this concept. Okay. Because if I putting any number between 2-digit number, I will get the value 1 point something only. Okay. So in the school, you must have referred to the log table, right?
Yes, sir.
Yeah.
Yes, sir.
In that also same thing is the number is there, and then value of this particular function is there. So if you observe that carefully, same thing you can observe. Like value of, say, log of 67, it will be something around 1 point something only. Right. So this is the concept of a log to the base 10, that is common base. So please remember, whenever such type of question is there, how many digits, so you have to always take log to the base 10, okay, of that particular number. It's a simple concept we have to remember. Okay. This one is interesting question. I try to solve it. I will wait for 2 minutes. Number of solution we have to find out. Okay. And here also base is different.
Solution is 0, sir.
How 0?
So I'm getting equation like x cube minus 3x plus 2 equal to.
Okay. So how shall I approach this?
You can write log x cube minus 1 divided by 3 log 2 equal to log x minus 1 divided by log 2. Log 2 you can cancel. X cube minus 1 equal to 3 times x minus 1.
So this is change of base rule, right?
Yes.
So log to the base c x minus 1, that is log to the base c of 2. So that's why in the beginning I'm saying just apply the change rule first and then apply the properties. Now I can write this 8 as 2 to the power cube.
Yes.
So I am just doing correction here. That will be 2 to the power cube, right? So it will be log of e x cube minus 1 3 ln of 2 equals to ln of x minus 1 ln of 2, right? So this ln of 2 will get cancelled. Now this 3 will go on this side. So what I will get? Log of to the base e x cube minus 1 3 log to the base e x minus 1, right? Now tell me, how shall I approach this? Anyone?
So we can take
We can take
3
to the
on the power
here.
Yeah, okay.
x minus 1 cube.
Yeah. So it will be ln of x minus 1 cube. Then
Now it will become x
Then
cube
we can
minus
take
1.
it to left hand side and
yeah,
x cube minus 3 upon me x minus 1 whole cube.
equals to 0, right? Then we apply that property x minus 1 cube equals to 0, right? Now tell me, after that,
So we can do e to power 0 on right hand side.
so e is there, means it will go in on that side, it will become e to the power 0, right? So I'm writing it here. So x cube minus 1 x minus 1 cube equals to e to the power 0. So that is 1, right? Now can I simplify this?
Yeah, so x cube minus 1 equal to x minus 1 the whole.
X minus 1
X
The whole
square
cube.
plus x plus 1
x square plus x plus 1 upon x minus 1 whole cube. So this will get cancelled and instead of it will be 2, right?
Yes.
Now it is equals to 1. Now it is x square plus x plus 1 equal to, I'm taking on this side, that is x minus
square.
1, sorry. So equals to x minus 1 square, again x square minus 2x plus 1. Now this
It
x
is not
square,
equal.
x cancel, right? 1 get cancelled, so 3x equals to 0. So I am getting x equals to 0 as the answer.
But
So
x equal
this,
to 0 does not satisfy that.
yeah. So if we put x equals to 0, this will become negative. If we put x equal, this will become negative, right? So it is not in the domain of this particular function. So the number of solution will be 0. It is not like the x equal to 0, it is 0. Its number of solution is not equals to 0. And instead of say it is plus 1 like this, and we are getting x equals to 0, then you can say number of solution will be x equals to 1, right? So it's 1. Hello, are you getting it what I'm saying?
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Okay.
Sir,
So
repeat
here number
please.
of solution. Yes, sorry.
Sir, repeat please when you said x equal to 0, the number sounds.
Yeah. So here I am getting x equal to 0 for this particular expression. But if I see my original function, so what is the domain of this particular function? So if I put x equal to 0, it will become negative, right? So our in the log function, our x always should be positive. Not x, f of x should always be positive, right? So it will become negative. So this is not valid. So this is also invalid for this. If we put x equals to 0 here, this negative become, right? So x equal to 0 is not a valid it is not in the domain of this particular function. So the number of solution will be 0. But suppose in the question it is x equals to, sorry, x plus 1, and now we are getting x equals to 0. Now it is okay, because here we are getting 1 and 1, it is positive 1, right? So in that case, the number of solution will be 1. But here we have minus sign, so that is, it is not satisfying, it is not in the domain of this particular function. So I can say number of solution is 0. Okay, any doubt? Anyone? You just have to do the calculation and you should know the properties that we have discussed. That's it. Okay, so now this question, just try it out. This is log of x2 plus log of 8y equals to 0. Same thing that I have said earlier. Try to apply the properties. How to get the expression? Yes, anyone?
The B option.
B.
No. The D option. X cube y equals to 1.
Okay.
Yes, sir.
Yes. Anyone? Any other student? Anyone?
AD.
Yes, sir.
Will also satisfy, right? When x equals to 2, it will
Yes,
become
sir. Yes.
8.
Yes, sir. Yes, sir.
1 by 8.
Yes.
Okay, great. So, yes, tell me the approach.
Base change method.
Formula.
Base change property, right? Okay. So, ln of 2, ln of
ln
x
of
plus ln of to the
ln of
power cube upon ln of y, then equals to 0, right? So, it will be ln of 2, ln of x plus 3, ln of 2, then ln of y. Okay, after that, what should I do? Yes, anyone?
ln to common. Then
ln2
replace
common. Okay, ln2 common, then 1 by ln of x plus 3 upon ln of y equals to 0. Then, so this is a particular number, right?
Yes,
So
sir.
it will go on this
We
side, so
can
it will
ignore
be
it.
0 only.
Can't
We
you?
can divide.
Yeah.
We can divide it by both the sides.
Yeah. So I am getting 1 upon ln of x plus 3 upon ln of y equals to 0. Now I can take this term on this side, right hand side. So 1 upon ln of x equals to minus 3 of ln of y. Okay, now tell me. Yes, anyone?
cross multiply.
Yes, ln of
Sir,
y.
reciprocal.
Yes, reciprocal.
Yes. Sir.
Okay. Now minus 3 will go on this power of x, right?
Yes.
By log
Yes.
property. Then ln of x to the power minus 3. Now tell me.
We can take it left hand side.
Left hand side. That is ln of y, ln of x cube. Like this.
Yes.
Or
Okay.
we can take exponential both the sides.
That way also we can take. But we can apply the rule here, right? Properties ln of y by x minus cube equals to 0. So
Yes.
that will be minus 3 will go on the numerator. It will become, I'm writing it here. So ln of x cube
By
y equals to 0. Now this is e, right?
Yes.
So e to the power
yes.
0, that is 1. So x cube
Yes.
y e to the power 0, that is 1. So this is the correct answer. And just try to put when x equals to 2, my y will be 1 by 8. So this is the correct option. This is also the correct option. Yes, anyone, any doubt in this part?
When ln of y is equal to ln of x to the power of -3, then can we not say y is equal to x to the power of -3 directly?
Directly, you cannot say that we can take anti-log, but yeah, but we can say that we generally do that thing only like this, but it is not preferable, right? We can simply follow this procedure, but it is same thing.
Because
Like
no,
we
I
saw
was
2
just
to
trying
the
to
power
kill the
x
time.
plus 1 equals to 2 to the power 5. So we are not considered, we always do like that only, right? X plus 1 equals to 5. But still you are taking the log on both the side and then you are applying this thing. So yes, you can say that directly also, no issue in that. Yes, anyone? Someone was saying. Hello? Okay. Okay, any doubt in this part? Anyone? So the important thing is that, so in any say log of f of x, my f of x should always be greater than 0. It should be in the domain of the particular function. Then just apply the, say, in most of the question I'm talking about, apply the change base rule. Okay, then apply the basic properties. Okay, so you can simplify any expression in logarithmic term. Okay, so that's it. Okay, so now this is the question. Okay, the set of all x for which there are no functions of the form f of x. So you have to find out the value or range for which this will not exist. You have to find out the value of those particular range for which no function of the form will exist. So basically, you have to skip that from the domain. So that range we have to find out. Yes, anyone? Just try out how to do that. Just apply the
What do
basic
you have to find?
value of x for which there are no functions of the form for this particular function. No function means it should not be in the domain of that particular function. We have to exclude that from the domain.
Okay.
Yeah.
-1 to 1.
-1 to 1. Which
Included
one, B
-1
or
to
C? Okay, including -1 to 1.
D.
Why?
On applying a scheme, sine scheme rule.
Sorry, which rule?
Sine scheme rule. Baby curve method to solve such type of inequalities.
Sinus king rule. Okay. But by applying the log properties, how we can solve this? Like what we have discussed today. So
We
we
can constrain on domain by using that it should be positive.
sorry.
And another
So
another
you can,
constraint on base.
yeah, you can compare with the general term log of x to the base a, where x should be greater than 0 and my base should be greater than 0 but not equals to 1. Okay, now just compare it with this thing. Yeah.
Yes, by it taking intersection of those both values, we came across -1 to 1, including -1 to 1.
Okay. So let us take this a part first. That is a minus 1, a plus 1. So I'm saying that a should be greater than 0 and it should not be equals to 1. Right?
Sir.
So from the options, if I put x equals to -1, then what I will get -2, 0, right? So that is infinity. That is not valid. So what is the domain of this particular, sorry, this not, when x equals to -1, this function is not valid, right?
Yes,
So
sir.
we can include that. And what is this function? X square plus 1, x square minus 1.
Should be greater than 0.
Yeah. So it should be greater than 0. So x square should be 1. So you can say x equals to plus minus 1, right? So if
Yes,
you
sir.
see, we have to include minus 1 and plus 1 here, right? So that's why
Yes,
it's
sir.
bracket. So option B is the correct one. Yes, anyone, any doubt? Just apply this basic thing that we have discussed. Yes?
So,
Uh,
no function means where vertical line test fails, I think.
Sorry?
No function means where vertical line test fails.
The vertical line function fails. Okay.
Vertical line test fails.
Okay, but how we'll apply
Means
in this
this is
question?
not.
That is not a function, right? We are talking about if vertical line fails, right?
Yes, sir. That is not function, and here it is written no function means it should not be function. Then we are.
Okay, but how should we know? For that, we should know the graph of that function, right? So
Yes, sir.
yeah. So if you compare with the generalized this term with the basic condition that we are saying, so my this particular function that is x square plus 1, that is my x square minus 1, it should always be greater than 0. So excluding
Yes, sir,
this range,
got it,
yeah,
got it. Yes, sir, I
excluding,
got it.
yeah. So excluding this to from range from this, it will become positive. Same for this thing
Yeah,
also.
yeah.
Yeah. So
Yes,
that's
sir.
why we have
Thank
to
you, sir.
include 1 and minus 1.
Yes, I got it. Got it.
Yeah.
So can explain
Okay.
again, so I didn't get it.
Okay. So no functions means we have to find out the range in which it will not satisfy this particular domain of this particular function. It will not fall in the domain of this function. So when I say this logarithmic function, if you compare with our generalized function, say log of x to the base a, our condition is x should be greater than 0 and this base a is greater than 0 and not equal to 1, right? So if you just compare with this, so this is my a, this whole term is my a. Sorry, x. So x square plus 1, x square upon minus 1. So it should be greater than 0. So for what value it will be less than 0, that will, for that particular value, it will be there will be no function, right? So means it will not be in the domain of this particular function. The domain of f of x, right? It is not included in the domain. So if you see, if I put any number between this range, the value of this particular function will become
Negative or 0.
negative. Yeah, it will become negative. So this is not valid, right? So it is not in the domain of this particular x. So it is excluded. So that's why for no function means that range, it is not included in the domain of this particular function. So that's why. And same you can apply for a also. That is x minus 1 upon x plus 1 should be greater than 0 and not equals to 1. So when I say it is not equals to 1, means this function is not valid when x equals to minus 1, right?
Yeah, I
So
see.
also we have to, yeah. So we have to include that minus 1 and 1.
Yeah,
Because
okay.
if you put 0 here, what you will get 1 upon minus 1, that is a negative value. So it will be negative function, right? So it is not valid. So that's why. Okay. So the option will be, correct option will be B here. Okay. So same thing, but here we have to find out domain of this particular function. Okay. So in the previous question, we have to find out the value which is not fall in the domain. Okay. But here we have to find out the domain of this particular function. Yes. Tell me how to find out. Anyone? Just try it out.
Log 10 base log x base 10 can be taken as t.
Okay, then.
Then we can apply constraint of a domain that it should be greater than 0, and we can find out a range domain for that particular, sorry, domain for that particular quadratic equation, and then we can compare with log 10.
Yeah. So value of this particular function should be greater than 0, right?
Yes, sir.
Yeah. So now just take that. Now I need to solve this particular expression. I can simply say that log of x to the base 10 is equals to t, right? So it will be t square minus 8t plus 15 greater than equal to 0. So what are the root of this expression? Anyone?
5 and 3.
5 and
5
3.
and 3.
Yeah, 5 and 3. That is when t equals to 5 and 3, right? So, but my t is log to the log of x to the base 10. So log of x to the base 10 equals to 5, or log of x to the base 10 equals to 3. So what is the value for x for this thing? Because 10 will go on this side, so it will be x equals to 10 to the power 5,
10 to the power 5 and 10 to the
and
power
here
3.
10 to the power 3. But this is greater than 0, right? So for this, yeah. Okay. So 10 to the power 3 and 10 to the power 5. This is the for this thing, it will be equal to 0. Then it should not be in between these two functions, right? Now tell me which will be the
Yes,
correct option. This is not correct. This is not correct. Option C or D? Yes,
C.
anyone?
C.
Okay, so we don't have to include that boundary thing like 10 to the power 3 and 10 to the power 5.
Yes, sir.
Just try to put here 10 to the power 3. So 10, 10, 3 square 9 minus 24 plus 15. It is 0, right? So do we need to include this thing or we have to exclude that?
Exclude.
Exclude.
Have to exclude that, right? Okay, so in between 10 to the power 3 and 10 to the power 5, my function is not valid, right? Here, between this thing, it will become negative, right? This value of this
Yes.
particular function. Yeah. So that's why option C is correct. Anyone, any doubt in this part?
No, sir.
Okay.
Sir, it will be
So
included now.
it will include?
Yes, 10 to the power 3.
But on this value, it becomes 0, which is not in the
Oh,
domain of log 10.
Okay, so understand it.
yeah, it should be greater than 0,
Oh,
right?
yes.
R value. Yeah.
So it's
So
domain now. Yes.
option C should be the correct one. Okay. So any doubt in activity question? Any activity question from week 6? Anyone?
Yes, sir.
Yes. Which question?
6.7 question 1. Activity 6.7
Hmm?
question 1.
This one, right? Okay. Let me share my screen. This question, right? Hello?
It is not visual, sir.
Oh, my screen is
Yes,
not
sir.
visible. This one.
Yeah. Now
Visible.
it is.
Yeah.
It is visible.
So you have to find out the
Yes.
value of this particular function only, that is m. So that is log of pi to the base 3 plus 1 upon log of pi to the base 4. Okay, we have to find out the value. So just apply the properties what I have discussed earlier. So how should we do that? Yes, anyone? Yes.
So log 3
Saurav?
plus log 4 divided by log 5.
Yeah. So I can directly write it as change of base rule, say ln of pi upon ln of 3, right? Plus 1 upon ln of pi upon ln of 3, sorry, ln of 4. Then this will go in the numerator, right? Ln of 3 upon ln of pi plus ln of 4 upon ln of pi. So it will be ln of 3 plus ln of 4 upon ln of pi. If you find out the value, it will be something around this range. 2 point something.
Oh, sorry, sir.
Yeah, that's it. Okay.
I
now
should
you can-
have calculated from calculator.
Yeah. You can use the calculator in the portal. It is given, and during exam also it will be there in the portal
Oh,
itself. Okay. So how many of you attempted the practice assignment question week 6? Yes, anyone? No one attempted the question practice assignment.
no.
Okay.
I have a doubt in activity question 6.1, question number.
Okay. 6.1.
Yes, sir. Question number 4.
Question number 4.
Sir, I have doubt in 5 also.
This we already discussed now, just now.
Yeah.
Question number 4. Yes.
Sir, I have doubt in question number 5, 6.1.
Yes. 1 minute. Srinivas, you have doubt in this question?
No, sir.
Okay. We have discussed this. So this is question number 5, right? Okay. Let me take this question. Okay. So yes, who asked this question? Yes, anyone? My screen is visible, right?
No, so yes, visible.
This question, right?
Yes.
Yuvraj? Okay. Yes, Pulkit, what is your doubt? Okay. You have to find out the domain of this particular
Domain.
function.
Yes,
So
sir.
what I said, this whole expression should be greater than
Greater
0,
than
right?
0. Yes.
Yeah. Here you can see negative term is there, right?
Yes, sir.
Negative sign is there. Erase there. Right. So means the value of this particular function should be negative. Then it will become positive, right? Negative.
Yes, sir.
Yeah. So we have to find out the domain for this particular thing. So how should I go? To the power x minus 27x equals to say 0. So for what value it will satisfy? This should be less than 0.
Less than 0. It
Yes.
should
Less than 0. What happened? This 1 minute.
It can also be 0 also.
So did you get why I'm
Can-
considering less than 0 here?
Yes, sir. Yes, sir.
Because
Yes,
in
sir.
the log you can see
It has to be
minus
minus, so that's why the
Yeah.
inner value has to be less than 0.
Negative
So
value,
that minus value actually multiplies with the inner minus, so it makes it positive. That's why it's
positive.
less than 0.
Yeah. That is correct. Yeah. So if you find out the root, so it will be x equals to 0. If you take the x common, it is equals to, say, if you equate to 0, at x equals to 0, and to the power x minus equals to 27. So you can simply book ln of 3 ex. So ln of 3 is the root here. So for when x equal to 0 and ln of 3, this function will be less than 0, means my between these two number, right? 0 and ln of 3. So it will become negative. So this term is negative means this negative will become positive. So my whole expression will become f of x will be greater than 0. I'm talking about this particular expression, right? So my option will be option C, 0 and ln of 3. Okay, any doubt, Pulkit, in this part?
No, sir.
Okay.
Activity 6.2.
Hmm?
6.2 question number 2 and 3.
Six point two, question number
2
2
and
and 3,
3.
right? Yeah. So which of the following statement is that true for the function uh, log of mod of x, right?
Yes.
So, okay. So how it will look the graph of this particular function mod of log of x? Let me see. Let me take this question. Okay. So, okay. Now tell me the graph of mod of x.
The mod of x is a V-shaped graph
Yeah, like
from the
this, right?
origin.
So mod of x means it will become positive when x is greater than 0, right?
Yes,
So
sir.
it will be minus x when x is
Less
less
than
than
0.
0. Yeah. Now if we apply the log here, in that case, what will be the graph? Yes, anyone?
Positive direction of x.
Positive direction of x.
X.
So for this side, it will be like this, right? This is y, this is x. And what about this thing left hand side when it is minus x?
It would be its mirror image, right?
Yeah. So it will be like this only on this side, right? It will not touch this particular y-axis, right?
Yeah,
It will not.
it would be very close, but it won't
Yeah.
touch.
So you can say a straight line when x equal to 0 is a asymptote for f of x, right? So this is x
Yes, sir.
equals to 0 line. Yeah. So graph will be look like this. So it will be just closer. It will not touch, and also it will like this. It is not an increasing function. Also, this is not correct. So graph is asymptote x equal to 0, right? Inverse is not possible. Then domain of is minus infinity to 0
So
and
this
0
is
to
also
minus.
true, right? I mean,
Yeah,
the
this is
domain
also
thing.
true. Yeah. So option B and C is the correct one. Sorry, B and D. Okay.
Third option
Now,
is not true, sir.
yes.
Why the third option is not true?
Which one?
Third option. Why is it false?
So, if we can we find out the inverse of this particular log of mod x? Inverse.
No, sir.
Just take, yeah, because here we are. It is a, if we see the condition mod of x, this minus of x when x equals greater than 0, right? So it should be 1-to-1 function, right?
Yes, sir.
To be inverse. So is it 1-to-1?
No, sir.
No,
No,
sir.
right?
It's not 1-to-1.
That's why we cannot find out the inverse. If it is 1-to-1, then we can find out the inverse. Okay. Okay. So third question also, right?
Sir, it's
Yes.
the x is equal, it is asymptote. What is that?
Asymptotic. What is that, right? Symptotics.
Yes.
Okay.
Yes.
So, just 1 minute. So asymptote meant asymptote means the line, it is the line to the horizontal or vertical for which the value of that particular function, so value of that, say any f of x will reach, but it will not be that particular value. It will just, like, if you see this example like this, the distance between the asymptote line and the that particular graph, it will become it will tends to become 0, but not 0, right? So distance between this particular line, say any line, and particular graph will tends to become 0. So that particular line, we can say it is asymptote. It can be vertical, it can be horizontal, it can be anything. Say for example, say this is my x equals to 1 and my graph is like this, right? So even if I increase, even if I go on the left hand side, like my graph will become closer to this x equals to 1, but it will not touch this particular line. Okay, that is asymptote. Here you can see this is vertical asymptote, and for horizontal also you can draw this line like this. Okay, so as I increasing the value of x here, my function will tends to this particular value, say y equals to b. Okay, it will tends to a particular value, but it will not reach that value. The distance between this y equals to b and this graph will tends to become 0. Will not equals to 0. Not equal to 0 means it will not touch this particular line. So that is asymptote. So here you can see in the graph, like what we have drawn for log of x. Okay, like this. So this is yx, that is x equals to 0, right? So it will not touch the x-axis. Sorry, it will not touch the y-axis, that is x equals to 0. It will approach the distance between this asymptote and this particular graph will approach the 0 distance, but it will not touch. Okay, so that is the asymptote. I hope you understand.
Yes, sir. Understood.
Yeah.
Sir,
Yeah.
one question, sir.
Mhm.
If log x, if there will be log x, then x is
Mhm.
equal to 0. Is there asymptote or
Yeah, x equal to 0 is asymptote for log
no?
of x.
If log of that mode will be not there,
Okay. No,
then
for
also
log of x, yes, it is x equal to 0 is the asymptote. For that, x equal to 0 is a vertical asymptote. Yeah.
yes, sir.
Okay. Now, third question, right? So this is the function, and which are the following is true. So log of x is 1-to-1 function, right? We have discussed that. And if it is 1-to-1, then it has inverse also.
Yes, sir.
So this is log of x. It is 1-to-1. The value will be in the real number only, right? So from 0 to infinity. So is also it will have 0 to infinity, and the whole value of this particular function is 0 to infinity, and it is 1-to-1. So this is correct, and it is 1-to-1. So f
That
has an
means
inverse also.
it will have an inverse.
Yeah. Yeah. So this is not correct. Okay. Any doubt in this problem? So
what's the domain of that function, sir?
domain of this particular function will be, this is the composite function, right?
Yes, sir.
So the range of this particular function will become domain for this particular function, and the domain of this the domain of the range of this particular function will be domain of this particular function. So domain of f is not 0 to infinity, it will be somewhere between any number. That we have to find out how to do that, but that is composite function, right? So x can take any value 0 to infinity. So you can see log of to the base 0 in infinity, anywhere between. So it will be between 0 to infinity, not 0 to infinity. It will not include. That is the domain. But it is a 1-1, so it has an inverse also. That is the case. Okay. Any other doubt in activity question?
Activity question 6.5, question number 2.
Are you?
Yes, sir.
Question 2.
Question number
This
2.
one. Okay. Suppose certain amount of money invested in mutual fund. Okay, let me take. What is the formula for compound interest?
T into 1 plus R upon 100 power time.
Okay. So here we have to find out certain amount of money invested in mutual fund. How long does it will take to triple in the assuming the compounded thrice year. So the formula for compound interest is P, say amount P, 1 plus R upon n into say T by 100, T into 100 into T into N, right? Hello?
Yes, sir.
Yeah. So what is R, what is T, what is N here? So basically T is the time period, right?
So T,
Oh,
T
sorry.
is T is
Yeah,
the
yeah.
compounding time, sir. I
Compounded.
mean,
Yeah,
half
yeah.
yearly
Sorry.
or quarterly or something.
N is the time
N
period
is the time, yeah.
in years, right?
Yeah,
And T is the number of times it is compounded, right?
yeah.
Number of times it compounded. This is then P is the principal amount, right? And R is the rate of interest, right? This is the formula. And here it is CI means say amount that will get after T years, say N years. So here what is saying? Triple the investment amount. Say suppose we have invested P amount, then in how long does it will take to triple the investment? So my amount here, that is A is equals to size of P, right? My R is 5%. Now compounded thrice a year means the value of T. So value of T is 3 here, right? And we have to find out the value of N, that is time period. So just put the value. So thrice of P equals to P 1 plus R 3 into 100 upon T 3 into N. So N we have to find out. So this P will get cancelled. 3 upon 1 plus 1 by 60, 3n, right? Now you have to solve this expression for n. Now using logarithm, how will you solve? How will you get the value of n? Yes, anyone?
We take log on both sides.
Yeah. Taking log on both sides, you can take natural log. So ln of 3 equals to ln of, you can find out the value of this 1 plus 1 by 60. That is say 61 by 60, right? Let me erase that. So it is 61 by 60 the power 3 by 3n. So this 3 will come in this side, right? Power rule. So 3n ln of 61 by 60. So what should be the value of n then? Ln of 3 upon ln of 61 by 60 into 1 by 3. Just put this value in the calculator, you will get the answer. Hello?
Yes, sir. Correct.
Yes, sir.
Just put the value in the calculator, you will get the answer of n. Okay.
See, sir, just a question. It would be, sir, something near value, right? Like, I think
Yeah, you will
we're
not
gonna
get the
get some near
approximate.
value, not exact
Yeah.
value, right?
Yeah.
Okay.
But you have to select the best option. So here, if you get say some 22.32, then 22 will be the answer, right?
Yeah.
Like
But
this.
sir,
Yeah.
another question. Suppose we are getting like 21 point something, like very close to 29. Let's say 21.9 or maybe 8, 7 something. So, so in that case, what option should we choose? Should we just do the round of thing and take 22, or
Yeah,
maybe we
22. Yeah.
just? Oh, okay.
Nearest
Got it.
value. Yeah.
Okay. Got it.
Yeah. While preparing the options, we'll make sure that such thing we will not keep like this 21, 22, right? So some difference will be there, 19, 22 like this.
Okay, sir.
Yeah.
No, sir, just ask for, like, just to be
Yeah.
clear in that situation. That's why.
Yeah. Okay. Sure. Okay. Any other doubt? Any other activity question?
6.7 question 2.
6.7 question 2 and 3.
6.7. Question 2 and 3. Question 3 we have discussed. Question 2. Okay. So consider the function as x is the greatest integer value. Then it is the point at which defined. So D is the infinite set. The cardinality of set D is this. Okay. What do we have to find out here? The D, right? Cardinality of D. Okay. So the value of this expression should be greater than 0, right? It should be positive. So D is a subset of R. Hello?
Oh, sir, the value of x is positive.
No. For any this function, this value of this whole function should be positive, right? It should be greater than 0 for logarithm function to be valid. Say like we have discussed, like log of x to the base a, so x should be greater than 0 always, right? So any function which is in the log, it should have the value greater than 0. Then only that function will be valid. Log function is valid. Okay. So there is subset D, which there is set of points at which f is defined. Okay. So yes, anyone can tell me. Okay, what is the greatest integer first? Yes, anyone? Greatest integer. Yes, anyone? What is greatest integer function?
Just taking integer part, ignoring fractional.
Okay, so if I say 4.666, then what will the greatest integer?
4.
Sorry, 4, yeah.
4, na?
4.
Right?
Yes.
Yeah. Say for example here, okay, let's take x equals to say 4.66 only. Then the value of x is 4.66, right? And what is the value of this particular function, greatest integer? 4 only.
4.
So difference between them is always positive. Is it so? Right?
Yes.
Difference between x and the greatest integer will be always positive.
Yes, sir.
So for any value of x, it will always positive. Means my function is defined.
Yes, sir.
Right?
It will be fractional part of that.
Yeah. So the set D will has infinite set, right? So it is set D is infinite. It can take any value for x.
So what if we
Real
take
number.
Integers?
Sorry.
So what if we
x is
take
less than
integers?
0, sir, minus.
For integers, it will be 0, I think.
So for integer, it will be 0. If
X
I
minus box of x.
yeah. So it will be 0.
But set is infinite.
Yeah, set is
set is
infinite, right? Yeah, that is correct. But we have to check the it is subset of this all real number, right? So set will be infinite only, right? We're finding out the cardinality of that particular set, right? We are not finding out the value. So the set will be infinite, means the cardinality of set, that is R, D is infinite, right? Which is also correct. Now the graph of x have infinite number of vertical asymptote. So for each value it will have one asymptote, right? So it is also correct. Now it is an invertible function on D. Anyone?
No.
No, right? It will not be invertible. And the range, I don't think it will be R. Range it will be R?
No, sir.
No. Actually range would be 0 to infinity, right? For this particular function.
So it's positive real line, sir.
Yeah, positive real line. Yeah. So R is not right. So 1, 2, 3 is correct. Okay. And who asked this question? Yes.
Can you repeat this Last.
Okay. So what I am saying, the value of this particular function should always be positive, that is greater than 0, right? My greatest integer function is like that if I consider, say, any value, say 4.66, so in that case my 4 will be the answer. If I say 5.11, so in that case 5 will be my answer. If it is negative number, say minus 3.2, then minus 4 will be the answer, right? But here the difference between these two things, it will always be positive, right?
So
Say
what happens
4,
if you're given a number like 4?
yeah, in that case it will be 0 again. But we are talking about the set, right? We are not finding out the value, right? So set will be infinite, right?
Yes, sir.
Yes, sir.
Yeah.
Yes,
So
sir.
the set will be infinite. The coordinate of set are not belonging D is also infinite. That is also correct. The graph of x will have infinite number of vertical asymptotes for each value. That is also correct. So A, B, C is the correct option. So when you are
Sir,
using
why
some
the
function,
E option is correct?
last option.
Yeah.
So range of this particular function will be 0 to infinity for any log function.
Okay, sir.
Yeah.
So
So
second
yeah.
option is correct, sir.
Second option, the coordinate of the set R slash D is infinite also. If set is D infinite, then R slash D is, it is not, that is also infinite, right?
No, R minus D, sir. R slash D
Yeah, R
means
minus D is also infinite, na then. We don't have that number, na. So R is also, it will take the infinite number of values. And the set
infinite
is also
value.
like, yeah. We don't know the exact value for that, so it will be infinite only, right? So the
why
graph
not
of its yes.
third option? Why is it close?
So for each value, you will get different asymptote, right?
Yeah,
So there
yes.
will be infinite number of asymptotes. Yeah, that is also correct. So that's why I said in the beginning, just keep focus. Whatever the function is given in the logarithm function, that value should be greater than 0. So in most of the question, we apply that concept, right? Yeah. Okay. So this question has already discussed. Okay. So if you join the session late, you can watch the recording. It is simply just apply the change of base rule, then do some simplification. You will get to know this answer. These two. Okay.
Sir, activity is 6.3, question number 4.
Okay. Question number 4.
You already
Actually,
discussed.
we already discussed this question. See, we have to find out the value of x here, right? And take the log on both the sides. So log of 1 will be 0,
Okay,
right? Now
yes.
e will go on this side, e to the power 0 is 1. Now we got 4 to x. Yeah, so just put 2 to the power x equals to 3, then try to solve this expression. You will get the answer x equals to 2. Yeah.
Okay, sir. Thank you.
Okay. Just watch the recording. We have discussed this question.
Yes.
Any other question?
In the previous question where log of x minus greatest integer of x question, that question, like
Yes.
how is the range 0 to infinity? I still didn't get that.
For this particular function, right?
Yes, sir. Range is not R, but what will
Yeah.
be the actual range?
Actual range that for general it will have 0 to infinity range, right? But we don't have the particular set values. It can take infinite value. So even if you take, say, any function, it will always be positive. The difference between this x and this greatest integer function will be always be positive, right? And that the value of this particular function will lie between 0 to infinity only.
Like for example, if we take x as some 3.66.
Yeah.
Then
So
x
3.66 minus 3, that is 0.66, right?
0.66. So that will be a negative value, right? Log of 0.66 is less than 1, less than 0.
Yeah, that is negative value, right?
So the range is also, it can also be negative, right?
Yes, sir, it will
Range
be
can be
minus
negative. Yes,
infinity to
negative value.
0.
Right.
Minus
Sorry.
infinity
Yeah.
to 0. Yeah, that.
Yeah. Sorry. Yeah. It will be minus infinity to
0.
infinity.
How can it be positive? It cannot be positive, right? Like if we
Yes. Right. It cannot be positive because the difference will always be less than 1, right?
1, yes.
It will be point only. Right. Great. Yeah, I missed that part. So it will be minus infinity to 0. Yeah. Yeah, thanks for pointing out. Yeah. What's your name?
Harsha.
Asha. Okay, fine. Okay. Anyone, any doubt? You have not gone to the practice assignment. Okay. I can discuss. I have time, so we can discuss one question. So simplification question. So this question we have discussed like compound interest. You can try out. This is very complex, a little bit complex simplification. Just try to solve. This is a practice assignment question number 1 only. Okay. So b is greater than 0 and this is the function. What is the possible value of x here? Same thing. Just tell me how to solve this question.
First and third.
Yeah, you have solved this, right? So that's okay.
Yes, sir. Today I have solved.
Okay. So I will take this question log to the 5. It is in the base, right? So b to the power 5 into x. So b to the power 5. B to the power 5 into x and then b. It is equals to 1. Then how to simplify this?
Base form.
Yeah, I can just apply the change of base rule. So if I have this thing log of b to the power x, so I can write it as 1 upon log of x to the power to the base b, right? So same you can do here. So log of x to the base b plus 9. Here it will be log of b, right, to the base b. So it will be b to the power 5. So it will be b to the power 5 x, right, equals to 1. Now we can apply that property power rule. So it will come on this side. So 4 log of x b plus 9 b to the power 5 x, right? Then log of b. Oh, no. That is not correct, right? It is b to the power 5 into x, right? It is not in the power. That is b to the power 5 into x. So I can apply this rule. Log of b to the base 5 plus log of b x, right? So it will be 4 of log of x to the base b plus 9 of 5, and this log of b to the base b is 1, right? So I'm directly writing out 1 here plus log of x to the base b, right? So I will get 4 log of b to the x, then 9 upon 5 plus log of x to the base b equals to 1. Now tell me how to solve this question, equation for x. Yes, anyone? How to solve this?
Log base b power x को t. Let it to be t.
Okay. So say log of x to the base b equals to t, right? So 4 upon t plus 9 upon 5 plus t equals to 1. Just simplify it then. Simple. 20 plus 40 plus 90, 5t plus t square equals to 1, right? Then 20 plus 40 plus 9t, right? So it will be equals to 5t plus t square. So what I will get? T square 13, right? So 13, it will go on that side. 5, that
Minus
is
8.
minus 8 of t, then minus 20 equals to 0. So what is the root of this expression? Yes, anyone?
10 and minus
10 and
minus
10 and minus 2.
Minus 2.
Yeah, 10 and minus 2. But what is our t here? This, right? So log of x to the base b equals to 10, or log of x to the base b equals to minus 2. Right? Now tell me. So from this, what I can say, x equals to b to the power 10, right? And from this, I can say x equals to b to the power minus 2. Hello?
Yes, sir.
So
Yes, sir.
that is the correct option. Okay, any doubt? Anyone?
No, sir.
No, sir.
Okay, just try out practice assignment question. I think we have released solution also. You can check the solution. Okay, or tomorrow again we have sessions. You can ask your doubt tomorrow also. No issue. So I will take this last question. Just you try to solve it and tell me the correct answer. We have discussed similar question just now. Those who have already solved this question, please wait for 1 or 2 minutes. Let others solve, then we can discuss. Same thing, same concept. Okay. Okay, anyone?
second, third, fourth.
So here also compounded. So compound interest formula. It is amount equal to principal 1 plus r upon t into 100, and that is t into n, right? So terminology we already discussed. So George deposit 5 lakh. Okay. Quarterly means t equals to 4. At the rate r equals to 20. How long it will take to increase this money 16 times? So a equals to 16p. So just put the values 16p, p 1 plus 20 upon 100 into 4 upon 4 into n. PP get cancelled, right? So 16, 1 plus 1 by 20, 4n, 16 equals to 21 by 20, 4n. Okay. Now just take the log. I think we don't have, just take the log on both the sides. So log of 16, log of 21 upon 20, 4 to the power n. So this will come down. So 4 to the power n, ln upon 21 by 20, right? So n equals to ln of 16, 4 into ln of 21 by 20. So option B is correct. Option C. Okay, we can simplify this also, right?
Sir, what is n?
Sorry, what is?
N.
N.
Yes, sir.
N is the year. In how many years it will be compounded? So T is the number of times it is compounded. So it is quarterly means 4 times, right? And here N is the year. So that is time period. N is in year. Okay. So we have to find out that only how long it will take to increase this money to 16 times the principal amount in years, right? So I can simplify this as ln 4 to the power 2, right? Wait, I want this, right? So 2 to the power 4, sorry,
2 to the
right?
power 4. Yeah, 2 to the power 4.
Yeah. So it will be 2 to the power 4, then 4 into ln of 21 by 20, and 4 will come this side, ln of 2, 4, ln of 21 by 20, 4 will get cancelled, you will get this option, right? If you by change of base property, if you apply in reverse, you will get this option also correct, right? So option B, C, D is the correct one. Anyone, any doubt in week 6, any question, activity or practice?
Sir, can you
Just
repeat this
yes.
question?
Okay. So which part? Like whole question?
Sir, in last 3-4 steps.
Okay. So here we have to find out the how long it will take to increase the money, right? So it is compounded. So we have to use a formula for compound interest. That is A equals to
Yes,
P
sir.
1 plus R upon T into 100 into 3 into N. So that is T is number of time it is compounded and N is the year. Now I am just putting the value A equals to 16P. Here P 1 plus 20 upon 100 into 4, right? Into N. So PP get cancelled. Now I have just multiplied here, cross multiplication. So 20 into 21, that 20 plus 1, that is 21. So 21 upon 20 to the power 4 by n. Now I have taken log on both the side. Taking natural log, that is ln on both the side. Okay. So that will be ln
Yes,
of
sir.
16 equals to ln of this into 4 to the 4n, right? So by the property 4n will come down, then you can simply write ln in 21 upon 20, right? So then just this the simplification is there.
Okay, sir.
Yeah. Okay,
Thank you, sir.
great. Okay, so just try to solve remaining practice assignment question. I think tomorrow we have one more session. You can ask your doubt tomorrow also, no issue. Okay, any doubt in week 6? It is simpler, nothing in it. Whatever I have discussed today, just take the summary of that. You can solve any question, right? So just try to solve, practice and read assignment question. That will be enough. Yeah. Okay. Any
Quiz
doubt?
2.
In quiz 2.
2, yeah, which will be on
Huh.
November 20.
Huh.
The syllabus will be from week 1 to 8 or from 5 to 8?
Week 1 to 8.
Okay.
Yeah. Because
Of
5
the
to 8
only
means like,
subject,
yeah. Yes.
of the only subjects which have chosen, right? Like, which I've selected which to continue. Like now I can choose, right, how many core
Yes, yes.
subjects I
Okay.
can take.
Yes, yes, for that courses. Week 1 to 8.
Okay, okay. Thank you.
For mathematics textbook, it is always week 1 to 8 because we can ask any concept from like week 2 in week 6 also, in this week also, right? The compounding
Yes, sir.
and
Yes.
composite function, yeah, that thing also you
Yes.
can ask. Finding out the range and domain from week 1. So that's why. This. Okay. Okay,
Sir,
thank you then.
sir,
Yes.
Thank you, sir.
is there
Thank you,
was
sir.
any session of qualifier like solving that questions?
For quiz
Qualifier?
question.
Yes.
No, no, not yet. I will ask the team. I will discuss with the team. Yeah. If it is
Okay.
there, you can check the calendar. It will be mentioned in the calendar. I am not sure about it. Yeah.
Okay, sir. Okay.
Yeah. Okay. So I think we are planning one session where all the instructor can meet all the students. So yeah, you can check the calendar for that. Yeah. It is not fixed yet. Yeah.
Okay, sir. I will check the calendar.
Sir, thank you, sir.
Okay. Thank you, everyone.
Thank you, sir.
Okay.
Thank you,
Okay.
sir.
Thank you, sir.
Thank you so very
Thank
much,
you,
sir.
sir.
Thank you. Good
Thank
night.
you, sir.
Good night, sir.
Good night, sir.
Good night. And I'm happy. Being happy. Be happy and you. I think. This is a